All right, physics folks, ladies and gentlemen, here we go. I want to do a clarification. And let me get my pen. Oh, that's white, don't need that. So we're going to clarify when to use x is equal to change of velocity over time, or x is equal to 1/2 vf plus vi times time. When do we use these? And this is a very important question because this will affect your answer on some of these problems, especially when we talked about two-dimensional motion. Now, this one is going to be when acceleration I can't spell. Acceleration is constant or zero. This means that we have constant velocity. Or the acceleration is constant throughout the experiment. This is acceleration is variable or unknown. So what the difference is that we know there's some type of acceleration here, but we don't know it. We know there's one present. Here we know it's constant or it's zero. There's no other forces acting on it. Now, how does that look on a problem? And that is key, is you got to know what's going on. And I've been guilty of this because it's very easy to go, oh, it's this one, oh, it's this one, and get it wrong. And this is what I'm trying to have you guys look at the bigger picture. And I'm going to be perfectly honest. Sometimes I fail at this too. Because you're going along, you're rushing, and you're like, oh, it's this one, oh, it's this one, oh, it's this one. And if you don't read the problem carefully, you will end up getting it wrong. And that's what I don't want you to do. So when we're looking at problems, if the problem will say acceleration is constant, or, and this is the hardest part, this is extremely hard, what the background indicates if something's happening or not. Shooting an arrow. The arrow's going this way. Is there, after it leaves the bow, is there any other forces other than gravity acting on it? If not, you use x is equal to change of velocity over change of time. If you know there's something acting on it and it's variable, then you use x is equal to 1/2 the average velocity times time. Here's the thing. These are totally two different velocities and two different answers. They're not going to give you the same answer. And that is key. And this is what we want to keep on telling you guys, what's happening in the background. Do you understand what's happening in the background? And it can be very difficult. So if on the test, write which one you're using, just and tell me why. Because if I'm looking for this one, and you say no, it's going to be this one because I think the acceleration varies, well, I'll give you that if it makes sense. This is why if you write everything down, everything what you think's happening, and write down what you think is happening in the problem, more credit, more points you'll get. Again, I'm just summing up why it's important to read the question and make sure you get the right equation. And like I said, I make this same mistake myself. It is easy to do, but I don't want you to do it. You need to slow down, figure out what the problem's asking, and if there's any other acceleration involved. Usually, if there is, the problem will say so. And that's another hint that say if the problem does not say there's acceleration or the acceleration is varied, use this one right here. All right, ladies and gentlemen, have a nice day.